The XBee IoT Smart Agriculture Demo is a complete end-to-end wireless IoT demo. It emulates the management of a smart irrigation system using Digi IoT devices and services. It demonstrates how Digi technology can be applied to this market, providing a smart solution to all the challenges you face when developing and setting up an installation like this. This specific demo is oriented at the smart agriculture vertical market. However, it can be applied to many other different use cases and applications easily. The demo showcases how to collect and process data from any device of the installation wirelessly and save it in the cloud, and monitor and manage any device of the installation remotely through a custom web-based front end using the Cloud API. The goal of the demo is to demonstrate the end-to-end connection technology using Digi products and services. The demo uses a Digi IX15 RF gateway as a central component. In this case, the device is called the irrigation controller. Several emulated sensors and a water tank that is emulated as well are attached to this device. In addition, 2 or more Digi XBee RF modules, in this case running the Zigbee protocol, are connected wirelessly to the gateway. Each of them have several sensors or actuators attached to them, for example a temperature sensor, battery and moisture sensor, and an electronic valve to control the irrigation status of this so-called irrigation station. All of these sensors and actuators are virtual, but the software that is provided by Digi, completely open and free of course, can be modified so that real sensors and actuators can be attached to the devices easily and quickly. The data is collected by the gateway or irrigation controller and then using a cellular connection, for example, uploaded to the Digi Remote Manager Cloud. Digi also provides a web-based application running on a computer to monitor and control the whole system. And finally, a smartphone can be used to connect over Bluetooth to both the gateway and each of the XBee modules to provision and configure the devices, as you would normally do in a real installation in the field. All of the software components required, the web application, the software running in the gateway, the MicroPython software running on the XBee module, as well as the smartphone application, are provided for free by Digi, so users can take them, modify them, and use them as starting points for their application developments. After the provisioning has been completed, and I will show this at the end of this video, you can access the demo main view using the web app that I mentioned earlier. You can run multiple demos at the same time, and on the start page of the demo you can select each of your installations. You can click on them and you see the position and if they are online, and then you can click the Explore button to get into the actual demo view. The irrigation controller collects data from the attached sensors periodically and uploads it to Digi Remote Manager. The irrigation stations report data from the attached sensors as well. The temperature sensor, the battery, moisture sensor, and the electronic valve, periodically to the irrigation controller. Then the irrigation controller uploads that data to Digi Remote Manager as well. The irrigation controller listens for requests coming from Digi Remote Manager, which the user can trigger using this web application to run actions such as the manual management of the tank and irrigation station valves. All of these messages, sensor data and commands are sent wirelessly to the XBee modules, where the programming simulates the behavior of the sensors and the actuators. When you send a command to open the valve on any of the irrigation stations, the LED on the development board will be lit to indicate that there was actual RF communication happening. The users can also create schedules that are used by the controller to automatically manage the irrigation system. Based on the irrigation schedule and moisture value of each station, the irrigation controller opens and closes the electronic valve of the different irrigation stations. Users can modify the weather conditions and the simulated time to see the scheduled task being executed automatically. In addition, users can review historic data for each sensor and actuator in the system, where the data is presented in a graph form. Let me show you how you can find the documentation of this demo. In the Digi IX15 Gateway User Guide that you can find linked on the product page on the Digi website, you will find a chapter Applications, Develop Python Applications, and then End-to-End Demos. In there, you will find a link to the XBee IoT Smart Agriculture demo. And if you click on that, it opens up the actual guide for the demo. Everything I just explained up to now is covered in the section 4. So get started, point 4, manage the installation. Everything I will explain in the rest of this video, which will be how to set up this demo and to get started with it, is covered in the chapters 1 to 3 of this Getting Started or Get Started guide. So let me now explain how to get started with the demo and how to set it up, including a simulation of a real-life commissioning, deploying devices as we would do in the field. You can follow the steps 1 to 3 as mentioned, or just follow the instructions in this video. First, make sure that you have all the components required to set up this demo. You will need one iX15 XBee gateway device and at least 2 XBee RF modules and their corresponding carrier boards. The preference is the XBee development board, which is the one with the USB-C connector. Connect the power, Ethernet and XBee antenna to the iX15 gateway and use the USB cables to connect the 2 or more development boards to your PC or laptop. And also please download the software package that you will require using this link in the documentation under Get Started, Configure the Devices. Also make sure that you have downloaded and installed the XCTU tool, which you can find in the requirements section to download. When that is done, open XCTU, click the Discover Radio Modules icon, make sure both or more serial ports are selected depending on the amount of development boards you are using. Click Next and Finish. Wait until the discovery process has found all of your development boards. Then click Add Selected Devices and check that all the development boards you have connected to your PC are visible here on the left side. Click on the first module in the list and wait until the parameters are read. And then click the little black triangle here next to the profile icon and choose Apply Configuration Profile. And navigate to the downloaded package Go into XBee3 modules to that folder and select one of the two XPro files, depending on which module type you have. If you have an XBee through-hole module, select the one with the TH in the file name. If you have a SMT or micro module, select the one without the TH in the file name. Open that and let it apply all the settings. Then repeat the same process with the second module and all other modules that you have connected. When all the modules are programmed, go to the web interface of the IX15 gateway. By default, it is using the IP address 192.168.2.1 or 210.1. So make sure to configure your laptop or PC accordingly to operate in the same local area network. And when you open the web interface, you have to log in with username and password. And by default, you need to use the unique password, which is printed on the label located on the bottom side of the device. Open the XBee menu in the top side and choose Profile Manager. Then click Upload Profile and select the correct profile from the demo package that we downloaded earlier, which you can find under XBee Gateway in the XBee Gateway folder. Just open this XPro file. Then again in the top menu, choose XBee Update Manager. Click Add Update Tasks. Select the file that we just uploaded, the IoT Agro Gateway file. Click Next. And select the module that is inside your gateway with role coordinator 16-bit address 4 zeros. Click Add and then Start Update. Next, go to System Device Configuration. Expand the Bluetooth section. Enable Bluetooth. Change the Bluetooth Low Energy identifier to Irrigation Controller. And change the password to 1234. Then click Apply. Next, go to System, File System. Click on Scripts and then use the Enter Directory icon. From here, click Upload, the Upload icon. And from the XBee Gateway folder, choose the .py file to upload the Python script to the gateway. Then go to System Device Configuration. Open System, Schedule Tasks, and there open Custom Scripts. Click Add Scripts or Add Script. Make sure it's enabled. The label can be XBee IoT Smart Agriculture Demo, which I'm going to copy from the documentation. Run mode is on boot. And under commands, we have to add 2 lines, which I also will copy from the documentation, which look like this. We can enable log script output and log script errors. Can leave maximum memory empty. Once can be off and sandbox should be on. Then click Apply. Finally, select System, reboot to reboot the IX15. The next steps are done using a smartphone to simulate the actual commissioning in the field. So far we just have set up the basics, and now we emulate to go into the field and install all the devices in an installation. Apps like these can be implemented using the XBee mobile SDK provided by Digi. In this case, make sure to download and install the Digi XBee Agriculture app from the Google Play Store or Apple App Store. In addition, you will need a Digi Remote Manager account. So if you don't have one yet, go to the Digi website and choose the links to create a Digi Remote Manager account, for example, a trial account. When you start the Digi XBee Agriculture app, you will see a menu in the top right corner with the 3 dots, and from there you can choose DRM credentials to add your DRM username and password. Let's provision the irrigation controller, so the gateway first. Click on the irrigation controller entry in the list, tap on it, enter the Bluetooth password that we set up before in the web interface, 1234 in this case, and tap OK. We'll connect to the device. And now you have to fill in several fields, which I will do quickly. Set the farm identifier to a value of your choice. This will be the same on all the devices that we are going to provision. Then the name of the gateway. In my case, I just called it IX15. You can name it as you want, of course. If the device is not yet provisioned in Digi Remote Manager, you may need to use the install code, which is located on the device. Make sure to activate main controller and then enter a network identifier. This is the PAN ID of the ZigBee network, which is like the SSID of your network. And you can use this icon to select it automatically, or you choose a value of your choice. You can set a network password and maybe also a GPS location of this device. When that is done, just tap Provision Device. And if everything works well, it will tell you that the device has been provisioned successfully. Hit OK, and back in the list select an irrigation station now to open its parameters. And in the parameters of the irrigation station, select a station identifier. This will be different on every module in the network. And then, as a network identifier, choose the one that we selected on the gateway. Also, you can set up a GPS location as before, and then again click Provision Device. Repeat the same on any other module in the network. The final step is to start the web application. For this, you have to have Python 3 installed, so make sure to have that installed. After that is done, go into the folder of your IoT Agriculture Demo package in the folder Web App and open a command prompt here. And then call the Python script run web app py from here using your Python interpreter. In my case, I have Python installed under Python 3.8, python.exe, and then the script run web app py, and this will start the web application. And also automatically open a web browser that will point to the application. Use your Digi Remote Manager user account, click Login, and you are ready to go. That concludes this session. Thanks for your attention.